Preparing for a site reliability engineering at Goldman Sachs interview? You've reached Candy Mentor, and this video is for you. We'll walk through 15 key questions you're likely to face. For each question, you'll see a sample answer, followed by the key points to cover. Subscribe, like, and share, and drop a topic request in the comments. Question 1. During market hours, a critical trading application suddenly shows elevated latency. How would you troubleshoot and mitigate it? I would first protect the business impact by checking alerts, dashboards, and recent changes, then declaring an incident if customer or trading flows are affected. I would compare service latency, error rate, dependency health, and infrastructure metrics to isolate the blast radius. If a deployment correlates, I roll back quickly rather than debug live. Communication matters. Keep traders, application owners, and operations updated with ETA, mitigation, and post-incident actions. While answering, focus on incident priority, blast radius assessment, golden signals, recent deployments, dependency checks, rollback strategy, stakeholder communication, and why speed plus risk control matters in financial environments. Question 2. How do SLIs, SLOs, and error budgets help an SRE team manage reliability? An SLI is the measurement, such as request success rate or P99 latency. An SLO is the target, for example, 99.95% availability during trading hours. The error budget is the allowed failure margin. I use error budgets to make release decisions. If reliability is healthy, teams can ship faster. If the budget is burned, we pause risky changes and focus on stability. It turns reliability from opinion into measurable engineering governance. Make sure to cover definitions, examples like availability and latency, how error budgets guide release velocity, and how SLOs balance reliability expectations with engineering delivery. Question 3. What types of toil have you seen in operations, and how would you automate them? Toil is repetitive operational work that does not create lasting value, like manually restarting services, rotating logs, provisioning standard access, or collecting health reports. I first identify high-frequency, low-judgment tasks from tickets and on-call notes. Then I automate with scripts, APIs, CI jobs, or self-service workflows with approvals. For a bank, I would include audit logs and access controls. Good automation is safe, repeatable, observable, and reduces both time spent and human error. In your answer, talk about repetitive manual work, ticket-driven tasks, operational risk, scripting, runbooks, self-service tooling, idempotency, and measuring time saved after automation. Question 4. A Linux server is running out of memory and applications are failing. What commands and reasoning would you use? I would start with free-m, top or htop, vnstat, and ps sorted by RSS to identify memory pressure and the biggest consumers. Then I would check dmesk or journalctl for OOM killer events. If it is containerized, I inspect cgroup linux because the host may look fine while a pod is constrained. Short-term, restart or scale the affected service if safe. Long-term, analyze heap dumps, leaks, traffic growth, and right-size linux. Be sure to mention memory metrics, process inspection, OOM killer logs, swap behavior, cgroups or containers, short-term mitigation, and longer-term capacity or memory leak analysis. Question 5. How would you debug a Kubernetes pod stuck in CrashLoopBackOff in a production environment? I would inspect the pod with kubectl describe to see events, exit codes, image pulls, probe failures, and scheduling issues. Then I would check kubectl logs and dash previous because the current container may restart too quickly. Common causes are bad config, missing secrets, failed dependencies, insufficient memory, or overly aggressive liveness probes. In production, I avoid experimenting blindly. If the issue follows a release, I roll back and then reproduce in staging for root cause. While answering, cover kubectl describe, logs, previous container logs, probes, resource limits, image or config issues, dependency failures, rollback, and avoiding disruptive production changes. Question 6. What makes a production alert actionable, and how would you reduce alert fatigue? An actionable alert tells the on-call engineer that user impact is likely and gives a clear next step. I prefer symptom alerts such as high error rate, SLO burn, or queue backlog, not every CPU spike. Each alert should have severity, owner, dashboard link, and runbook. To reduce fatigue, I deduplicate related alerts, tune thresholds using historical data, remove non-actionable pages, and route warnings separately. The goal is trust. When the pager fires, it matters. Make sure to cover symptom-based alerts, severity levels, thresholds, runbooks, ownership, deduplication, suppression, SLO-based alerting, and why noisy alerts weaken on-call response. Question 7. How would you perform capacity planning for a high-volume financial application before a major market event? I would start with historical traffic, order volume, latency, CPU, memory, database load, and downstream dependency limits. Then, I would model expected peak plus a safety multiplier, especially around market opens, burnings events, or volatility spikes. I would run load and stress tests that include realistic request mixes, not just synthetic happy paths. Capacity planning also means checking queues, connection pools, and third-party limits. I want documented headroom, clear rollback options, and dashboards ready before the event. In your answer, discuss baseline traffic, peak multipliers, stress testing, headroom, dependency capacity, auto-scaling limits, rollback plans, and validating assumptions before business-critical events. Question 8. How do you design a safe deployment process for a critical service at Goldman Sachs? For a critical financial service, I would combine speed with controls. The pipeline should run unit, integration, security, and regression tests, then deploy through lower environments before production. In production, I prefer canary or blue-green releases with automated health checks on latency, errors, and business metrics. If signals degrade, rollback should be fast and rehearsed. Because this is regulated, I would also preserve change records, approvals, artifact versions, and audit trails. Be sure to mention CI/CD controls, automated testing, canary releases, blue-green deployments, approvals, observability, rollback automation, change records, and compliance expectations in regulated systems. Question 9. What is your approach to high availability and disaster recovery for a business-critical platform? High availability keeps the service running through common failures. Disaster recovery restores it after larger failures. I start by defining RTO and RPO with business owners, because a trading workflow may need far stricter targets than a reporting tool. Then I design redundancy across instances, zones, databases, queues, and network paths. Backups alone are not DR. I would regularly test failover, validate data consistency, update runbooks, and measure actual recovery time against the target. While answering, focus on redundancy, multi-zone or multi-region design, RTO, RPO, failover testing, data replication, runbooks, dependency mapping, and avoiding untested recovery plans. Question 10. A service is timing out because database queries became slow after a release. How would you investigate? I would compare pre-release and post-release database metrics, query latency, throughput, locks, CPU, I/O, connection count, and slow query logs. Then I would identify whether a new query pattern, missing index, ORM change, or a larger transaction is responsible. Execution plans are key because a small code change can trigger a full table scan. If customer impact is high, I roll back first. Afterward, I fix the query, add tests, and improve database observability. Make sure to cover query latency, execution plans, indexes, connection pools, lock contention, deployment diff, rollback criteria, database metrics, and collaboration with application and DBA teams. Question 11. Why is stateless service design important for reliability, and when is state unavoidable? Stateless services are easier to scale and recover because any instance can handle any request. Load balancers can move traffic away from failed nodes without losing user context. In practice, I externalize state into databases, distributed caches, object storage, or message queues. State is unavoidable for databases, queues, and some low-latency caches, so those need replication, backups, and consistency controls. The reliability pattern is simple. Keep compute disposable, and manage state deliberately. In your answer, talk about horizontal scaling, load balancing, failover, session management, externalized state, caches, databases, consistency, and trade-offs when stateful systems are required. Question 12. How would you troubleshoot intermittent connectivity issues between two services? Intermittent network issues require evidence from both ends. I would check error patterns, affected hosts, timing, DNS resolution, load balancer health, firewall changes, TLS failures, and connection pool exhaustion. Tools like ping, traceroute, dig, curl, TCP dump, and service mesh telemetry can narrow the layer involved. I would also compare successful and failed paths. Before changing configuration, I want logs, packet captures, and metrics proving the cause, because random network tweaks can create bigger outages. Be sure to mention DNS, routing, firewall rules, load balancers, TLS, packet loss, latency, retries, connection pools, service discovery, and collecting evidence before changing production configuration. Question 13. How do security and compliance requirements affect the way an SRE operates production systems in a bank? In banking, reliability work must be secure and auditable. I would use least privilege, role-based access, just-in-time elevation, and strong logging for production actions. Secrets should live in a vault, not scripts or environment files without control. Changes need traceability: who approved, what changed, when, and how it was verified. Security patching also becomes an SRE concern because vulnerable systems are unreliable systems. The key is building compliant workflows that are still fast during incidents. While answering, cover least privilege, privileged access management, audit logging, secrets handling, encryption, change management, vulnerability patching, segregation of duties, and balancing reliability with regulatory controls. Question 14. What role do configuration management and infrastructure as code play in SRE? Infrastructure as code makes environments reproducible, instead of relying on tribal knowledge and manual server edits. I would manage infrastructure, deployment settings, monitoring rules, and runbook-linked automation through version control and peer review. This reduces configuration drift and makes rollback clearer. For production, I prefer immutable or declarative changes where possible. Rebuild or reconcile rather than patch manually. Sensitive values should be separated through secret management. The benefit is faster recovery and fewer surprise differences between environments. Make sure to cover reproducibility, drift prevention, peer review, version control, immutable infrastructure, rollback, environment consistency, secret separation, and safer recovery after failures. Question 15. What should a good post-incident review include after a production outage? A strong post-incident review is blameless, but very specific. It should include customer or business impact, detection time, response timeline, contributing factors, root cause, and where our tooling or process failed. I also capture what went well, because those behaviors should be repeated. The most important output is action items with owners and due dates, tests, alerts, automation, design fixes, or runbook updates. Without follow-through, a post-mortem becomes documentation, not reliability improvement. In your answer, discuss blameless culture, timeline, impact, detection gaps, root and contributing causes, what went well, action items, ownership, deadlines, and preventing recurrence. If you are still with us, congratulations, you are much ahead of the rest and serious about preparing for your interview. We hope we were able to add value to your preparation and create some helpful content. Do not forget to like and share this video. Your small act can do great things for us.